Man, there are so many drawings to look through. Wait, did I remember to look at the electrical set too? I need a way to make this easier.
Is there anything I could help with?
Yeah, if you could make these drawings a lot easier to go through, that would be amazing.
Actually, I can. We should take a look at the model to get a better idea of what it looks like.
Heard that the model is really helpful, but I have to ask, how can it make reading through all these drawings easier? Hey, I need the model for that. I really need to see that in 3D so I can visualize the design better. Can you get me the model for my team to take a look at?
Okay, no problem. Let me reach out to the VDC coordinator. Hey there, can you get me the models?
Yeah, no problem. Which one do you need?
I think the one for everything? Or actually, I'm not sure. I thought there was just one. Could you tell me a little bit more about the ones you have?
Do either of these scenarios seem familiar? Or maybe you've just come across the simple question, I understand there's a model, but what exactly is it? It's not unusual to feel like the definition of the model can seem a bit confusing, and I get it. It's something new, or you haven't had a chance to be taught what the heck the model actually is, or even had it explained. Let me take a few minutes to explain for you what the model is and the different types of models you may come across or hear someone referring to. Once you understand these different types of BIM models, it may become easier to understand what the BIM model is and frankly how it can begin to make finding or confirming information on the project much easier. Okay, so let's start with the basics. What is a model? When you get right down to it, a model is a file. Sure, okay, we know it's a file, but what is the significance of it? Well, it is a file that is created in a program called Revit. There are other programs out there just like Revit, but it's fairly safe to assume that Revit would be the program used to make a model that you could be looking at. If you know what AutoCAD is, Revit is essentially the next evolution in design drafting programs used to make a precise representation of the design electronically, just like AutoCAD, but instead it's in 3D. So what the heck is Revit? Revit is a program that composes the model, or rather drafts the design in 3D, as I've said earlier, and it creates the 2D drawings from that 3D design. And now here in 3D view in Revit, as you would imagine, you can see the 3D model of the design. The drawings that are used to build the project are from the Revit model. Essentially, the project drawings and the 3D Revit model are the same design information, just presented in different ways. So what does the 3D part have to do with it? Well, the thing with this type of drafting program is that the design is actually a bunch of 3D geometry, essentially geometric shapes that are called elements, representing components of a building like floor, column, cabinet, window, roof, lights, piping, ductwork, HVAC, electrical equipment, and fixtures. These pieces of geometry are quite precise in their size and their spatial location in a design model, and ultimately the building itself. And they can create a 3D environment representing the design intent. It sounds like a video game, and frankly, in some ways, it is, in that both have an environment that you both explore, except in a BIM model, it is an exact virtual representation of something that is being built, rather than just a game. Some of these elements are very detailed models that are called families. These are models within an overall Revit model. Families are inserted into the model and can be anything ranging from a specialized piece of equipment such as a pump, generator, hospital patient lift, or even something as simple as a toilet, a chair, or a table, and even a concrete column. Most manufacturers make families of their products available, which makes the model much more representative of the real-world shape and size of these pieces of equipment, fixtures, or products, and in turn makes the design coordination with these building components much more accurate. A valuable attribute of elements is that they have properties about them that displays qualitative and quantitative information on the element, like its dimensions, assembly type, its color, its product manufacturer, or a building system it belongs to, or even what level it's located in. Just like specifications and, to some extent, the drawings, the properties of an element tell us a lot of critical information about the elements of a model. This means that at the click of a mouse, we are able to see information on or specifications about an item. In summary, models are a series of 3D shapes that represent and communicate the building design intent within a 3D environment. Let's now look into the different types of models you will come across on a project. Now that we have a basic level of understanding of what a model is, we can explore further into the different types of models in the construction sense. An easy way to look at it is to break the types down into 4 overall categories. First is the design models made by designers, usually the architect or the engineers for a specific design discipline. Secondly are trade fabrication models, which are made by the subtrades to show a trade-specific scope of work. Third is placeholder models, meant to create spatial boundaries for an object or design aspect. And fourth is the overall coordination model or federated model. These are made from the design, trade, and placeholder models, all combined into one singular model for coordinating the work virtually. Let's talk about design models. There are generally several different types, the first of which is architectural models, and these usually represent the fit and finish of a building interior and/or exterior, like walls, windows, floors, doors, furniture, and fixtures as a minimum. Next is the structural model, representing the structure of a building, whether it be cast-in-place concrete or structural steel, and in some newer designs as of lately, wood. Next are the mechanical models, which usually represent the main plumbing and HVAC systems within a building. The fire protection models represent the fire suppression or sprinkler systems within a building. Now lastly, the electrical model. These represent all electrical systems, fixtures, devices, and equipment. Trade fabrication models are models that replicate a model from a specific design discipline that represents the trade scope of work and shows the trade's specific intended routing and takes the design model to a higher level of coordination and detail. This higher level of detail is a result of ongoing and/or completed coordination amongst the other subtrades, showing the intended field routing, system, hangers, connections, and the other coordination with adjacent services in the same space. Typically, trade models would take precedence when reviewing a coordination model above the design models, as this shows the real intended routing. However, trade models will be largely based off the original design model as mentioned earlier, that relates to the trade model scope of work that it represents. Generally, the types of trade models you can expect to see on a project are plumbing, HVAC, fire protection, electrical for conduits and sometimes fixtures, and in some instances, structural steel, and window glazing. Placeholder models represent a scope that isn't captured in design models or in trade models either. Its purpose is to convey important information, including but not limited to aspects in the design that may not be reflected in design models, scopes of work that aren't captured in a specific trade model, temporary structures that could have an impact on the construction of a building, and logistics planning. Typically, these are meant to create spatial boundaries within the model to help for planning and coordination purposes. So what does that all mean? Well, some examples of common placeholders could be minimum headroom clearances in spaces that don't have finished ceilings like arcades, outer boundaries of equipment in place of detailed equipment families to ensure space is provided for that equipment or object. Also, in some instances, the service clearance will be provided for a piece of equipment as well. Temporary structures like cranes or man lifts, elevator service runs, insulation applied to the underside of a structure, and sometimes bearing zones for shallow foundations to represent the bearing zone that could undermine the foundation if it is dug up. Coordination models are a combination of three categories of models, all shown in one single model and aligned so that in combination with each other, they show a full representation of the building's design intent within a 3D environment. This combination of the design model, the trade models, and various placeholder models, if there are any, is to show the original design intent supplemented with the subtrades coordinated routing of primary building systems and services, as well as supplementary information from placeholders as one complete holistic model. Anyone interacting or referencing the coordination model can get a clear visualization of the overall design intent while being able to review precise or specific information on an area or specific scope while having the context of all building design and/or trade scopes all visible at the same time in one single environment. Now, the primary difference between the last three types of models and the coordination model, aside from the fact that the coordination model is a combination of all three, is that the coordination model is hosted and shown in a program called Navisworks that is meant for navigating these coordination models and performing coordination efforts to find and resolve interferences.